Hello and welcome back to our sixth installment of the Business Web Practices Speaker Series. Today I have the pleasure to introduce a returning speaker, and her name is Jane Croft. So let's give it up for Jane.
Okay, everybody can hear me, I hope. So, hello, my name is Jane Croft. I'm a quality control senior analyst for Anthem, which is the national healthcare insurance company. That's all you hear from me about the company. What we're going to talk about today is the standard common practices of quality assurance with software development. And let me start here. Of course, this is my gorgeous picture up here. So, let me tell you a little bit how I got to Croft. It had a long, strange path, but it's all been in healthcare. I first graduated from Baylor University in Waco, Texas. Yes, it is the same Baylor University you hear about the football games and all that. We're getting there. So out of that, I had a decision to make whether if I want to go pursue healthcare or education. So weighing the pros and cons, I decided to go pursue healthcare. So having that said, I jumped right into it and I went to a county hospital district in Fort Worth, Texas. And I started as a lowly, humble HR assistant who brought order to chaos. So from that point forward, my reputation maintained from that statement to bring order to chaos has does stand true to this day. So all of my career has been my reputation. Having that said, I really wanted to get into IT, but it was a hard challenge for me to get in there. So I did manage to get into the home health agency of that same hospital district. I was a one-person IT department. Network, ordering equipment, moving offices, designing the office, telling them where to wire the offices, deal with all of the production issue events. Did the month-end processing, the whole 9 yards. So with the jack of all trades, it was a very fun job. Unfortunately, that organization at the time had two vice presidents who was not really inclusive, and it got to a point where I had to resign that position, unfortunately. When that forces me to move back to my home in Houston, Texas, and I was unemployed for a while, sadly, but I did get into an HMO company, and at that point I became a business system analyst. This is where the IT career started to kick in. I learned how to make requirements, and I'm telling you, that is the most critical career skill I've developed, is having clear, concise requirements. From that point forward, I got into laid off again. Then I went to a startup company in California. At that point, they were designing software from scratch using Java. And I had to write the requirement for that. I had to design the screen, telling what each field does, how the function works, where it stores in what database, what happens if the user press this button, and so on. So that was a very extremely fun job. I had the most fun in that job. Unfortunately, we could never secure our first client. Our money ran out. So I ended it off again. Yeah. But fortunately for me, because of that relationship with that company, WildPoint was just a few blocks down in that same city. I got into that company as a contractor, as a business system analyst in California. From that point forward, I realized I had a problem. I could write requirements, I could create them, but I was a terrible troubleshooter. I mean, I just could not troubleshoot and debug production issues so bad. So my days in IT was not all that happy at the time, and I didn't have a very good boss either. Fortunately for me, they had a reorganization, moved me and dumped me in QA, and I said, hallelujah, I found the perfect department for me. So, and I have the perfect department, I have the perfect company, and I'm working on my way to the perfect position, which is going to be the manager. I'm right now in management training. So across my fingers, 2 years, I may even come back as a manager if Bruce let me. So that is this long, strange path going through. Despite all of this, I'm deaf. I was born deaf. The only thing I cannot do is telephones. So most of my career was prior to the ADA. That's showing you my age right now. So this is prior to the ADA. So I had to oversell a lot of my skill to compensate for the lack of phones until the ADA came, the American Disability Act. That protected my job. I relaxed. I can then relax. Fortunately, technology finally started to catch up. So I have closed caption phones is what I use today. And when we go through the presentation, you will hear various stories along the way with my QA life and my desk life merged together with software development. Now, as I mentioned earlier, I have a cloud of skills. These are my skills and attributes that I'm famous for. Yes, I do tend to brag, and I have to. It's the way to self-advocate my career and to self-advocate my skill set. So, I am a database designer. I'm an awesome project manager, which I think is the fun part of my job. I'm certifiable IT geek. I would rather buy technology than clothes. So I have no sense of fashion whatsoever. I thought I was doing pretty good for today. With the approval of my friend, though. I am a data platform seeker. I always seek for data everywhere. I'm trying to collect data as a source of information to help improve the process I'm dealing with. Yes, I'm deaf. And notice this is a lowercase deaf, not a capital D deaf. There's a reason. I am not considered a part of the capital D deaf culture. I'm in that gray area where it has the life of both. I can speak, and I can use the phone very well, but I don't know American Sign Language silence. So I'm in one of the gray areas. I do not have a cochlear implant, although I can be qualified for it, but right now I'm too busy with that. So as I snap my mouth, maybe later. I am also the Disability Associate Resource Group within my company. We have over 50,000 employees in my company. I represent those groups. I have no idea how many people are disabled in my company. You will never know. That's protected by the law. But I am an advocate for that. And I'm a fabulous business system analyst. I make awesome requirements. And most of my developers and programmers in the past have loved me because I always write very clear, concise requirements. Name and language. I'm not high in vocabulary. I do not like big words. I use very simple words and put into a documentation. And sometimes I scare people because they give me an assignment and I produce something in 2 hours. They go, wow, how did you do this in 2 hours? I just do. But that is why I have such a good relationship with my developer system. I am a little bit OCD on process, organization, and tracking. I follow up. I am a stickler for process, and there's a reason for it. In QA life, you will have that. I consider myself a rock star. My boss thinks so, which is good. I am a team leader. Right now, as a management trainee, I'm moving away from my assigned project to helping me managing my team. So there's a lot of management tasks that I'm doing for my boss, which is beyond my job description right now. So hopefully that will move forward. I am a self-taught HTML coder. I did it for fun many years ago. Then I realized I keep forgetting the bloody semicolons, or I cannot troubleshoot my coding. Forget that. But I have a greater appreciation how much effort a developer will go into coding from my experience. As an application designer, statistical data digger, technology advocate, a terrible system troubleshooter, as I mentioned, designer, and all of this, I work from home 100% here in Richfield, Washington. So that was a real big perk that I got. Now let's talk about quality. What is quality? Expectation versus reality. When you see something you want to buy, what makes your decision to say this is a good quality versus another company's version of the same product? What separates those two? It's your expectation of the product that you want to seek. It's what declares you has a higher quality. What if you have a product that didn't meet your expectations? The reality became something else. So quality is a constant management between expectation and reality. However, it's everywhere. It's not just in product. Product is easier to understand because it's tangible. It's something you can touch and smell and feel with. But service is harder because service is based on each individual experience. So how do you know if your experience is different from somebody else's experience and still produce the same quality? So there is best practices and governance rules to apply consistently, no matter what your experience is. It's actually defining quality in service. Amazon is a classic example. You can buy a product, which is the product one. Then you have the service of Amazon, whether it's shipping delivered on time, or whether you got the right size, and so on. So it's two components always stay together when it comes to quality. Now, let's do a little exercise here. I have up here on the screen is what's considered a requirement of a product. So what am I? The tape, color imitation leather straps. Each strap is attached with an edge. One is the crossover with the rhinestones. There's a buckle. Then each may have a loop. And then you repeat the above for a second copy. So what is this? Can anybody guess? It's a shoe. This is the shoe. And how many requirements this takes? That's a lot. But I also see there's a lot of errors. If you're trying to design a product, write off those requirements. How do you know it's going to come out exactly like this? You have to test it. That's why you're a prototype. Because you build a prototype and you put it in writing and say consistently for every product you have these attributes. When these become the requirements of a shoe. So this looks simple, but it's really complex. Each requirement has different attributes of the shoe. The sandal, the heel, how many rhinestones, how many straps, how it's wrapped around, how many size, how many inches. I can go on and on forever. You as a developer, in a similar way with websites, how do you know what you're going to see on the screen until somebody tells you? Or what's going to happen to that screen when you press save? Where does it go? There's a huge mountain behind the web world, beyond it. So it can go to a server, it can go to a database, it can go to another system for its own processing and so on. So all of that is wrapped there. The web is just a front door. And more important is your 5-second impression to the customers. If your website is not clear, concise, and navigable, how is your customer going to feel confident to go through your website for that product or that service? It's 5-second impression is all you get. And that's why website is very important. It's your front door into all of that. Here's the answer for that same product on Amazon. Now, how many of you would consider the color of your shoe? Would you consider this beige, nude, brown, or cream?
White.
It's cream, but when you look at it in person, your perception of the color may be different. that company has to have a product that standardizes the color so that it will be consistent for every type of shoe with that color. That's an example of quality. Now, IT and QA, we have a love-hate relationship. Please love us. I beg. And this cartoon is a classic example. On the upper left, you see two bears. You, the developer, says, how can I make it? You want to create something. We, the creator, comes up and says, I'm going to break it. And we say it with a smiley face. The reason why we have to break it, we want to make sure that your system or your code, your website, whatever system you're working, is actually working in every possible scenario. However, it is technically impossible to create every single possible scenario in the world. So we are trained to hunt and find and make it broken. That's why we say, can we break it? Now down in the other cartoons, in the classic example too, a developer, when you do your first testing, you want to make sure it's working, so you do your own testing. And then you find out, oh, phooey, I made a huge error. So you think you have one hit against you. But we, the QA people, suffer more, which is the other guy with a whole bunch of errors saying, oh, that's nothing. We get blamed for finding too many. That's our QA life. But we don't mind because we are here to help you. Our job is not to nitpick you or put you into a negative light. Our job is to make sure your code is a high quality output so that you will produce a better work over time. And also benefit the company that way as well. That is the purpose of career, so don't hate us. Love us. I have seen many developers from a career where they really hate us. They think we're like mothers, nagging, like the wives nagging them. Well, that's the way we do. That's our job. But we do it for a reason. We're here to help you. We're all your partners to make sure that your outcome of your work is in high quality. Now let's do a classic case study. This is going on famously right now. Both products were sent out to the public at the same time. Apple and Samsung Note 7. So, would you consider the Apple as a better quality versus the Samsung Note 7 that exploded, now the FAA banning and so on? Would you say that? Yes or no? This is a trick question actually. Apple 7 may be a good quality, but they saved their butt by adding another requirement to have an adapter for that missing plug that everybody was complaining about. If they had not done that, it would have been a disaster. So it was an add-on cost for them to say, whoops, we made a mistake. What about the other people who have the other technology? So they have to make an extra requirement to make that happen. So it can be good or it can be bad, depending on the timing. Of course, I don't know. I don't have any company inside information to answer that. Now, Samsung, exploding, they found the root cause of the problem. According to Mashable.com, it's because of the ion batteries inside the phone is too close to the plate. And what happens when you get too close to the plate, the chemistry inside the battery heats up and explodes. So is it really Samsung's fault or not? Samsung took a risk to use that technology, the ion battery, which has a history of exploding prior to Samsung. So they took the risk of using that technology for the product. But it's not their product, it's somebody else's, but they have to use it in order to make the product. So the trick question here, but who gets the blame? Samsung. They lost $5 billion of revenue because they had to stop making this product due to this defect. So my question when I heard the news, I said to myself, who tested it? Did anybody test the battery? They made an assumption to use that battery in that product thinking it's going to be fine. They did not test, obviously, with that iron battery over time in that product, and they get the money. So that's two questions. Now, in the QA world, we have different layers of quality assurance. You're going to hear QA a lot, but they have QC. QC is a subset of QA. QA is purposely a strategy to procedure-wise to make sure all of the requirement is filled in compliance. In other words, they manage the expectation by spelling out and prevent defects. It's a governance body, meaning that every product, every service must follow this procedure, must follow this path of testing, must have these documentation, must have these evidence to make sure that every single part of the service that comes out follows the exact same procedure. That's correct. QC, which is where I'm from, we actually hunt for defects. This is the testing world. So we go inside and we hunt for defects to make sure that it's working. But we don't decide whether to move it to live or move it to production. The business unit or the business user who signed off that work makes that decision. You know, this is sad. Sometimes we want to say no, and then they say, no, we're going to ignore you, we'll just go ahead and do it. That has happened. It's one of the biggest frustrations of QA life. Our purpose is to define the actual reality. Does the reality match the expectation? Yes or no? If it does, it passes. Yay. If it does not, it fails. We also use it for detecting defects. We hunt for defects. Now, there is an ongoing debate on what the relationship between QA and QC. A lot of them say they go side by side like yin and yang. I don't agree. I think it's inside of QA. So this is a hierarchy type of structure. IT goes first. SDLC means software development lifecycle. Every single company, whether it's IT is small, medium, or large, should always have a software development lifecycle methodology policy. That policy defines the actual process of QA from coding to QA to sending that to the public. The implementation. It's very important that as a developer, when you start a new company, get to know your company SDLC policy. Then underneath that, you have quality management, which is basically the management team of quality. They manage the budget, the resources, the testers, onshore, offshore, whoever. And QA is actually the governing body, which is what I was talking about earlier. Then quality control, that's me here, we test. And then testing and defect management is underneath that. That is the hierarchy of QA life. Now, in the software development lifecycle, every company has a different practice, but this is the common, this is the typical process. You start with requirement. I'm going to say, give you a requirement here, what you're going to build. You guys take it and say, programming, make it happen. And you're making it happen in the environment that is not live yet, but not even test environment. It's just some development environment. You're putting on this. When you think everything is going fine, you cross your fingers, you say a little prayer, then you send it off to testing. That's when we pick it up, we test in that test environment. There is an IT department usually that manages the promotion of the code from the development environment into the test environment. And your company may have multiple test environments. It could be 3, it could be 5, it could be 10, who knows? And then whatever code is being put in there, we test inside that mind. Then if everything goes well, we pass, and the threshold of passing rate is good, and the business user says it looks good, then sign it off, then move forward to release. And this is also means implementation too. They're usually that same people who promote the code along the way also promote into releases. Now I used to be a part of the release team. It's every weekend for 12 hours. The management team will bring 3 boxes of pizza, sugar donuts, Mountain Dew, to manage for 12 hours in implementation because it's a downtime for the customers. So we have to hurry up and get all of this implemented, check it out, do a checkout, making sure everything's working, and then give it back to the consumer. This is what you see online. This system is down, momentarily down for maintenance. Remember, that's what we're doing behind the scenes. So you think there's one page, oh yeah, it's probably going to be down in a couple hours. We're working like a dog behind the scenes to get it back. That's what we're doing. And I tell you, it was fun, keeps you on your toes. There's a lot of partnership going on when that happens. And it's a very condensed, very stressful time. So the good team you have, the more you work together in testing, prevents any potential release problems. So the more we test, the more we can relax a little bit in the release. Then obviously after everything goes live, you have to maintain it. It can get broken again, which is possible. That becomes a production issue. Something that had been working for months, whoops, got broken again. So somebody had to go back and then fix the code and start the cycle all over again. So this is the ongoing cycle forever. Now, in the QA wall, or actually quality control, there's different testing types. This is the common testing type we deal with. You IT developers code, if it doesn't look good, promote to a unit environment. This is the smallest testing environment for them to test. And it's just a simple test of your code line, that's it. No, nothing fancy. Then it gets promoted to SIT, System Integration Testing. That's me. We're the first line of testing team to really dig in and find your defects. That is a huge testing component. If everything goes well in a certain time frame based on the SDLC methodology policy, sometimes the policy says we have 12 weeks to test. Sometimes it says 4 weeks. It depends. And you have to do it within a certain days. So it's a very compressed, condensed time for us to hurry up and test. That's SRT. Everything looks past on the technical and business side. Then we promote it to unit UAT, which is user acceptance testing. That's where the business people come in and say, yeah, it's working. As a business user, if I'm pretending I'm a customer, I'm testing, it's working for me. Or if it's not working for me. They are pivotal. They are the ones who actually sign off the results. If they do sign off, then we can go forward for implementation. If it does not get signed off, something not satisfactory, or something gets failed, stop the process. We have pulled out the code from the release. And that's more work for the IT team to do. This is the one everything else they're doing at the same time. So we have to pull it out and try again. We'll go through that whole cycle again. That's why it's so important with Croft. Be clear and concise as possible. In the beginning, we'll have less headaches along the way. And how well we test by all different directions also helps along the way. Now there are other testing types like E2E, which is end-to-end, or regression. Those are the kind of testing where the system does it on its own, hands off, no user intervention. Just having the system pretend it was a live data and see if it works. There's a slight difference between end-to-end regression. Regression is when they try to find different scenarios, even if the scenario doesn't make sense. End-to-end is more of a common production scenario that does make sense, and there's a reason for that. We want to hunt for defects, and those defects can show up in regression as well. Then the bottom, we have a system performance or parallel test. Not every company do this, and it can be overlooked. It is basically a technical server type of issue. A while back, when Twitter first became popular, we kept seeing the dead tweet bird all the time because everybody was crashing the server because the system performance of the server is poor. They did not anticipate this growth so fast. So they have to invest in new server to accommodate that demand. That is our typical system performance parallel testing. So they test the new equipment with the old and see if it improves the speed, the saving, the stability of the system, and so on. So that's what they do. Test automation. I have a little note about test automation. It can happen anytime in testing. Test automation does not mean robotics things. It means it's like a macro. If you want a system to perform a task automatically on its own instead of a manual person doing it, let's say for a website you have a form and you want to test the form, you can create a macro to fill out the form for you. That is a form of automation tools, and it can be done inside the test environment. It is a wonderful thing to have, but we can't be too dependent on it, because even the tool itself can have bugs. And I have seen that. So we can use a mix of manual tester as well as automation tool together, and that would be a higher quality. As I mentioned before, unit testing is the smallest testable part in an application where the individual unit or individual code is being tested. This is commonly tested by the developers use. You're double checking your work. That's what it is. And it's in that particular environment. You want to make sure it's not going to add on you. Add means something that's just totally broken on you, or equivalent of old Windows DOS, then the blue screen of death. That is considered admin. Okay. You don't want to have any code collision. For example, with this shoe, we say cream color, but what happens if one developer says it's beige, and the other developer says cream, and somebody says it's brown? That's a collision, because your code is not matching, and it interferes with the other. That's a collision. We have to eliminate that collision. Those collisions become defects if you don't fix it. Now, system integration testing and user acceptance testing have two very different mindsets. They may test in the same environment in two different time frames, but for very two different strategies. SRT is purposely hunting for defects like Elmo's bird in the forest, hunting for his rabbit. That's what we do. And that picture is the classic example. When the tester enters 0, 0, 0, 0, 0 in the date field, the developer said, "Why are you doing that? That's silly." We, SRT, said, "No, it's not silly. It's a scenario. We have to test it. It's not a real life scenario, but we're using it. We want to make sure it's going to work. Is it going to be been in front of you, somebody put 0, 0, 0, 0 all the way?" That's what we do. User acceptance testing is validate the system is working expected for that business. Doesn't meet the user expectations. For example, this shoe came out clean. Did they have the right size? Did they have the right price? That's what user acceptance is looking for. SRT we're looking, did it fall apart? Do I have the right rhinestone? Do I have the right count of rhinestone? Is the heel right? That's the SRT. So there are two different strategies. Now, in the life cycle of testing, this is within the QA. Okay, what you've seen before was the life of the IT with QA involved. This is QA itself alone. And we do our analysis. Once you finish your coding, you send us the code. And then you give us, okay, these are the requirements that is applied to this set of codes. We have to analyze the requirements. These requirements are business and technical requirements. They don't have any scenarios, so to speak. We have to analyze it and create scenarios. That becomes test planning. We create a test plan to say, this is how we're going to test it. What kind of data we're going to use. How often we need to test it. And when. And by who. All that planning goes in advance. Now, one thing very important, this is where my job comes into play. If I'm assigned to a project, I have the critical job of doing level of effort, LOE. That means you're charging billable hours for our work into it. The tester lead will contact the testing team. That testing team will say back to the test lead, there are going to be 50 test cases to test this shoe. I'm going to ask how much it's going to cost. So 50 test cases equals how many hours of work? Time, so many dollars per hour. That's LOE. I have to approve it, make sure it sounds reasonable. Make sure we're not overlooking something. I would hate to overlook something and say, oh my God, we forgot to test that. That would be the worst thing we want to do. Then I have to pass that information to the project manager. They have to approve it. We don't. They approve it, put it in their budget. That becomes their time sheet so they can report the time on. So that is a huge component of test planning. But I'm telling you, there is a lot of negotiation that's happening. ITPM comes and says, hey, whoa, that's way too expensive. How come it costs more than the development? Or with a one-line code change, why are you costing me 10 times more? This is where I come in and say, whoa, one-line code means 100 test cases fold. Do not ever assume a simple line coding means a very simple testing. That is never true. We have to look at each case by itself alone. So one simple line coding could be hundreds of test cases to test. And on the flip side, sometimes the development spends so many hours in a big mega project. It turned out to be very small testing, except for me. It depends on what system you're testing. A mega project can have 6 or 7 mega subsystems, including the website. Each of those subsystems will have its own testing team. Each of those testing teams will have its own separate testing testers. So you imagine the layers. So it can triple, quadruple, extensively, even for a simple project. That's why I asked about the Samsung Note 7. What happened? Somebody did not test the battery. Now with the lag of QA that it didn't even make sense. We should have included them in. Then, after we finally figured out the plan, everybody agreed to it, then we promote the coding to the test environment. This is when you, the developer, say, goodbye, good luck, Let's hope it works. It's all yours. Okay, forever hold your peace. No more coding, stop. We test in the test environment. We do it multiple test environments. It could be 4, 3, 5, 6, 10, whatever system it is. If everything goes well through those testing types that you saw earlier, unit, SIP, UAT, PAL, on so on, then we can start executing. Now, test data setup occurs during test environment. Remember those test cases I was talking about earlier? Well, they agree we're going to do 50. Okay, we need to create the data. So we go inside the test environment and create the data before we execute. Now what we mean by executing, we're doing a function. Let's say on the website, we are going to create the data we want to use for your website. The execution is actually doing the functions. That's the execution. If everything goes well, crossing our fingers, we get the UAT sign off, ready to go to live production, become the test closer. This is where we get all of our paperwork updated, sign off, document. Sign off everything, and then we have the actual authority to move forward to the implementation. That's the sign off. Now, going back to the test execution, the typical task that we do during execution. Now, remember, execution could be 12 weeks, 6 weeks, 4 weeks. That's a lot of work to do in that time frame. We create the scenarios, we document it. We figure out how we're going to do that execution. Step 1, do this. Step 2, do this. Step 3, do this on the screen. And if it produced this result, do this stuff, do this stuff. That scripts. Then we have to make sure the environment is ready, so we have to hear from the developer, is your code in the test environment yet? Is it? That's why you have a separate IT team managing that point, so they can convey back and say, all system go. So we cross our fingers. Hopefully we won't have to say, Houston, we have a problem. So then we do regression. Sometimes we copy the code to multiple environments for different testing reasons. One may be a regression that can execute the SIT execute the we hold off the UAT until SIT is finished, and so on. Then we actually execute. We document the results. Okay, test case 1. Did it work expected according to the script? Yes, pass. And so on, bam, whatever. Then we keep up with the metrics. This is what my job does. How many test cases do we have? How many passed? How many failed? How many more test cases do we have to add on? Sometimes during the execution we realize, we need to add one more scenario. We plug it in. So sometimes it's extended down because we have to do that. So we keep up all of that. If a defect is found or something did not work during execution, we have to document that. We go back to the IT teams. I hate to be the bearer of bad news, but your thing didn't work. This is why. So that becomes a defect. So we keep up with all of that. There's a constant flow going on all the time. This is what I do every day. Now, obviously, in the testing world, we have different results. Pass, fail, inclusive. Sometimes the system behaves and we say, wait a minute, the system doesn't look right. This is not what the business unit thought. But it could still be right. Let's consult with them. Say, were you expecting this? This is what we did. And then they can evaluate for us whether that's okay or not. Sometimes they skip a step, and then it turns out it produces a different output, but it turned out to be okay. But we can't declare that. We have to let the business people tell us, say, yeah, okay, it looks good, all right, it's acceptable. Or we can defer it. Well, we have 200 test cases, fine, you only finish 150 of it. So we ask the business partners, Do we want to delay, postpone the release to finish the 50? Or do we want to go ahead and use the 150 and then defer the other 50 test cases later? Business makes that decision. We do not. IT do not. That's why the business has the burden of the output of all of your products and services. Then, of course, we may have a situation where it's totally out of our scope. That usually occurs when you're assigned to a certain subsystem that is not in your scope, may belong to another testing team, or a scenario that will never happen in testing world. But we documenting, say we have a test case for it, but we'll declare it out of scope. So that way we at least address it. Do not create test cases and say, oh, let's delete that. No. We never delete our test cases. We either report one of those statuses. If it's something that is not testable, we just put it out of scope. So at least the business partner will know, well, we thought of it, but we realized it's not going to be functional. So therefore, we take it out of scope. The business partner will say, okay, I accept that. Or they say, no, hell no, I don't accept that. Sometimes that's where the negotiation comes back into play. So, wait a minute, why didn't you test this scenario? That doesn't make sense. It's out of our scope. Why? Here's why. Oh, okay. So let's contact this team. Let them do that part. That's just a common scenario. Now, if we find something broken, it can happen different times. There are three major defects. Testing, warranty, and production issue. Testing defect means something got broken during the actual testing execution. And then we go back to the IT, we need to double check your work. Can you fix that for us? And then you go through the same cycle. Now, warranty fixes is when you, after you already went to production, and then within the first 45, 60 days after those, people start watching it to make sure it's working like a surveillance. And if something gets broken during that time, it's under warranty of your work. And that's warranty fix. Same fixing happens. Same cycle, it's just in different time frames. Now, production issue is more serious. What happened when you went years later? Somebody messed up the year. This happened famously in the year 2000. In 1999 became year 2000. Everybody started freaking out. No, what's going to happen when you have the last two date field of the year? So it can come back to haunt us. So what happened was something got fixed, went through production, and then somebody made an old code re-exist, or somebody had a collision that broke it again. That becomes a production issue. The bigger problem with production issue, it put a big bad taste mouth for that business. Because it's broken. Wait a minute, how come it's broken? You mess it up. And guess who gets the blame? We do. We do. So we have to move quickly. Unfortunately, this is on top of everything else we're doing. The business always says, I want it fixed yesterday. The IT team says, I want to fix it now. The QA says, we'll fix it in the next release. Now you see why IT and QA sometimes have a love-hate relationship. No. We are not going to pressure in because we need to go through our own process to improve the quality of that code again. Let's go back to the Samsung Note 7 issue. Did it pass or fail? Apple. It's considered pass only because they added an extra requirement for their adapter. Otherwise, it would have been a failure. It's very possible they did testing and they said, ooh, we found a testing defect. Let's hurry up and make a new product for the adapter. That's probably how they got out of it. Samsung Note 7, the blame is not on Samsung, it's on the third party. The business signed off that risk. So is it the fault of Samsung? We tested, everything looked good. It explodes. But the business signed off on it. So what can you do? So is it a fail? It's a trick question again. In Samsung Note 7 situation, it is a fail because of that collaboration did not work. But it's also a pass because Samsung tested everything prior to sending off. So how do we know? We will never know. We will never know exactly what has happened. All we know is what the root cause, and that is a production issue. It exploded after they made the product, sold it to the public. It started exploding. Production issue. What is the severity? 1. Critical. In defect management, there are 4 severity. 1 is critical. 2, urgent. 3, medium. 4, low. Usually cosmetic, like typos, that kind of thing. But that explosion was critical 1. What did they do? They had to do damage control, stop production. Did a PR, FAA start banning, so on. That is a production issue. Now, how can they come back and recover what they did? And this just found out 2 days ago. They used the same functionality that was on that Note 7 to another product. So hopefully they can recoup the same customer there. It's not Note 7, it's something else. It's one of the tablets, I believe. So they moved the same function to that was tested and passed into another product. So that's a person. The 10 commandments of QA. Know your customer, including those with disabilities. You saw that Amazon webpage. How do you know if Mr. Bruce, Professor Bruce, can see that picture? Every website should be accommodated for customers with disabilities because you are a front door exposure to the customer. You do not know what kind of customer is looking up in your website. You really don't. You have a count. You don't know the people. They're behind the scenes. Deaf people, it's the same way. Closed captioning. If you have a video to show a service or something, make sure it's closed captioned. A lot of the major social media companies like Facebook, YouTube, and one other company, Google, have its own team of IT people, developers who have disabilities, and they test their stuff through their experiences. And they follow the W3, I think it's called the W3 IT worldwide standards. And there's a huge chapter in there what we need to do to make your website accessible for those people with disabilities. Know your IT methodology and practices. That's one of the very first things that developers do when they get hired into a new company is learning about that. And usually that takes a long time. It takes several releases before they finally get the hang of it. Be engaged in positive partner of IT, please, like us. So we're there to help you. You're there to help us. Demand clear, concise, specific requirements. I cannot tell you how many times a defect was found because somebody did not write it wrong. I know the defect you saw earlier has full of errors, does not look like anything like this. So if you follow that requirement, it's going to fail because it does not look like the prototype at all. Save so much headache by making sure your business system is writes up clear, concise, specific requirements. Never assume the assumption. Samsung Note 7 classic case. They assume the iron battery will work for them. It will fail. You can document your assumption you can make test cases into assumptions, but never ignore it. I never even read the assumptions, even though it's there, but I don't even use it. I just go ahead and make positive, negative test cases. If it's 000 date bill versus 999 date bill versus 8/16/2016. So I have all these different types of test cases. Always be cautious of the risk. And this is something that some may have done, but we don't ever know. Did they ever realize there was a risk with the batteries? If you know there is going to be a risk, whatever testing, it's the risk of not having enough people to finish testing, or the risk of something that's not working right, we're not confident that it's going to work in production, are you willing to take that risk? It is important for the QA team to be very vocal about it. Our job to come to you and say, we found something that may be a risk. Are you aware of it? They talk about it. And then the business decides whether to stop everything or move forward with caution. So that's be very conscious of it. Do not cave into pressure to deliver. The reason why I got really suspicious of Apple and Samsung is both came out at the same time, which makes me wonder if they cave into pressure because they knew Apple was going to deliver, therefore they deliver this. Do not be dependent on tools, automation tools. As I mentioned before, have a mix of different types of testing style and types makes a high quality. Defects are not your mistakes. This is where the positive partnership comes in. It's an opportunity for you to make the correction to improve the quality, so that all three programmers will have the exact same cream color of the shoe. Use that as an opportunity to learn and say, wait a minute, why did it not, my code did not work on this? There may be something I overlooked or did not learn about or did not know about. There are too many interfacing systems to know everything. It's not possible. Sometimes you may have to consult with somebody else to say, why did that not work? Many companies have what you call a technical team, where it's a body of people who are very experienced developers who go and take a look at your code. They can do that. It's called a review, some sort of technical review. Sometimes they do that prior to testing, just to double check. And please document. I cannot tell you how many times we found a defect that reappeared after 5 years, and my developer had to go back into the code, letting understand what was the original intent, because they did not write the reason. The document. It's a pain in the butt. IT hates documentation. QA loves it. So document exactly what your code is designed to do and what the function is supposed to do, so that if it reappears 5 years later, we know what you were intending to do in the first place. Then we can evaluate whether it's still relevant or not. Bottom line, the partnership, IT, QA, QC, and quality software. The partnership with these three makes a world of difference. This is a picture of me that's working from home on conference call, average 60 of my 8 hours a day. And killer captain. This is what I do every day. Have fun doing it. And that's what I look like. Pardon me, I had a bad hair day that day. But that's what I was doing. I am in a constant state of negotiating, talking to people, reviewing material, responding to email, helping my testing team when they need escalation. I'm the first point of escalation. I negotiate with the IT ability for my testing team. I'm not going to pull them away from their execution. They're busy. I'm helping them to say, okay, we got a problem. You need to work on it. Then give them back the answer. So that's my life right here. I have 2 slides in here that is for your benefit if you ever want to get it from Bruce. One is just simply a lesson learned from a career over the years, and all the various career resources that you can learn more about. They do have certification programs. So it's up to you if you want to pursue that. So anybody have any questions or discussion about the world of QA?
Dave?
Yeah, go ahead.
When Obamacare rolled out and when the Oregon healthcare system rolled out, they were both colossal failures. So do you have any insight into what happened with those?
Well, that's very hard to say. That is why it's so important to document everything so that if something goes wrong, you can go back and say, why did we assume this way? That got off track. Or the system is behaving differently than it was written. Why is that? Sometimes you have to do a more investigation to find out why. So sometimes my test execution can stop dead in its tracks because of that. So hopefully not. That's the worst case scenario for us to stop everything. So sometimes we have to stop to let the developer go back and see why that relationship with the two code collided. And sometimes it's something that was hard coded from years ago. Nowadays we have database, we have tables, we have other floating type of data that eliminate the hard coding, but some still exists. And sometimes it won't reappear until a very specific scenario, which is why we have to document everything we do. So we can go back and say, this is how we did it, and this is why it appeared, and this is what it did. Then the developer will say, ooh, I never checked that area. Then we go, look. So that's why we're improving your quality at the same time.
It could have been a poor specification. It could have been, a million things. So I don't know what the root cause of that
It
system
always
was.
amazed me because there were people that on their own put together, functional websites that in 48 hours.
Yeah, but this is a lot. That system is a lot more complex than someone can build in 48 hours.
Well, to her point though, maybe it was they were trying to adapt it to old systems and they couldn't communicate properly.
If you think about all the exchanges and all the companies involved and integrations with their systems, it was probably a huge specification. And just know that as a guy who came from software, that it's always hard to please that user on the that end user, no matter what you do, and then all the things that you forgot in the specification phase that were when you go to roll it out and someone somewhere is saying, what about this system here? It's not updating there. Oh, it happens all the time. So, who else? Dave.
Do you integrate with intellectual property?
Do you integrate with intellectual property?
Intellectual property department. It seems to me that a lot of crossover between how you specify things when you're writing patents and how you specify design requirements. The language and the level at which you're writing looks pretty close to me. And I'm wondering if you ever work with the intellectual property departments. Do your specifications ever find their way into patents?
So do the specifications that you write ever cross over into the world of intellectual property? Is there some division in the insurance company that deals with intellectual property of things that you develop?
Everything we write is within our own QA IT world. That is why I said QA is a part of IT. There are companies out there that really have two separate departments. I don't like that because it's really the two is joined to the hip.
Yeah. So
everything we document is owned by IT. So QA is just simply managing the expectation of the product that is created by IT and the service by IT.
Jane, what Dave said was intellectual property. Property.
Well, with the intellectual property, when I used to work as a that company from scratch. We have to, there's a contract of some kind for the testing team to sign, especially offshore testing team, so we can the document, the testing evidence, the product, the prototype, whatever, is owned by that company. And anything out of that scope, we're in violation of. There is a huge regulation body that monitors that. Depending on what company you're in, my company is a health insurance company. We're governed by a lot of federal laws on the PHI, private personal information, SOX, HIPAA, I could go on forever. So every person we're in contact with has to sign a contract. Now, it's part of my employment agreement as well. But my offshore team has to sign a contract saying they only have access to certain types of data. And speaking of which, when we're talking about test environment here, we never have ever have access to the live environment ever. Test environment is all we do. We only go to the development environment. We're only authorized in that single environment, which may explain why some testing teams have to do some work for us, because we not have the security authority to run certain functions, so we may have to depend on the IT team to run a batch job for us, or run something behind the scenes for us, because in QA Life, we're not developers, we're analysts. The only exception is the animation tools. That's where our developers are.
What tools do you use, by the way? Tools. What tools?
Beta. We talked about.
What kind of automation tools?
It's like a macro. Like, for instance, if you want to sign up for fill out a web form, you can create a macro to have the system automatically fill it out for you and press save. Or if you have a database update that is done behind the scenes on the schedule, run it. There's no user intervention involved. For example, if you have to do a batch job in the test environment, we can automatically schedule for 10 p.m. that night and see if we can see the output the next day. Those are the kind of automation tools that happen. Unfortunately, it does not fit for every single scenario because the developers have to create the animation tools. And even the self can have bugs and defects. So it's just for the purpose of ease for us, especially when you're dealing with thousands of test cases in a big project. It is impossible for my testing team, which maybe have 15 people, to type in all the test data, create all the test data in the test environment manually. So we use the automation tool to create that data for us.
Is that IBM Jazz?
Huh?
Is it IBM Jazz?
No, it's not like that.
Okay.
It's more of a mainframe type of thing, but we do use IBM tools.
Okay.
We do use
Rational.
rational tools application of that for documentation. But there are other IBM tools that they use to automate. So yeah.
Okay. Anything else for Jane today? Let's give Jane a big round of applause.